So good day, ma'am. I'm Michelle Amamangpang, and my partner is Vince Randall Rustia, and we are the reporters of Week 11. So let's start. Solidification process. So what is solidification? Solidification is a phase transition which is liquid turns into solid when its temperature is lowered below its freezing point. Why to study in detail? The solidification of metals and their alloys is important in various industrial processes. Most of the components produced from the metals are by casting process. When a metal is welded, a small portion of metal near weld melts and resolidifies. So this is a diagram of solidification. Liquid, solid. Then here's the temperature. So during the solidification, the liquid changes into solid as cooling proceeds. The energy of liquid is less than that of the solid above the melting point. Hence, liquid is stable above the melting point. But below the melting point, the energy of liquid becomes more than that of the solid. Hence, below the melting point, the solid becomes more stable than the liquid. Thermodynamically, both liquid and solid have equal energy at melting point, and therefore both are equally stable at melting point. Freezing is almost always the exothermic process, meaning that the liquid changes into solid, heat is released. This heat must be continually removed from the freezing liquid or the freezing process will stop. The energy released upon freezing is a latent heat and it's the entropy part. Some undercooling will be essential for solidification. Solidification occurs by two processes, the nucleation and the growth. So, the cooling curves. So, this is the diagram of the cooling curves. You can see the liquid phase, the solid phase, and the freezing point. Here, the time, and then this is the temperature. So, a cooling curve is a graphical plot of the changes in temperature with time for a material over the entire temperature range through which it causes total heat to be removed for solidification. And this is the formula for solidification. This is the cooling curve, this is undercooling. So, kato kaniya kay cooling curves, and this is the cooling curve for undercooling. So we can see the temperature, and this is the undercooling, the evolution of heat under the undercooling, and this is the time. So next is driving force for solidification. So solidification is undoubtedly the most important processing route for metals and the alloys. For a pure metal as the fusion temperature, and this is the formula. So this is the nucleation. So the first step of the metal solidification is the creation of tiny, stable nuclei and the liquid metal. So cooling the liquid below its equilibrium freezing temperature or undercooling provides the driving force for solidification. Once a cluster reaches the critical size, it becomes a stable nucleus and continues to grow. The mold walls and the Na solid particles present in the liquid make nucleation easier though. So this is the kanang rotation for nucleation. First is the cluster of atoms, embryo, nuclei, crystals, grains. So back to the embryo, back to the cluster atom. So R means the critical radius. So nucleon nucleation, the nucleation is the volume freeze energy to freeze free energy difference between the liquid and the solid. So this is the formula of volume energy. So next is the surface energy. The energy needed to the create surface for the spherical particles. So this is the formula of surface energy. So specific surface energy are the particles. So this is the Y stands for specific surface energy for the particle. So next is total free energy changes. So this is the formula of energy change. At the low temperature, atoms from the small of groups embryo form may either form into stable nuclei or may redissolve at the liquid. Beyond the critical radius of the nuclei, it will remain stable and growth occurs. So this is the diagram of nucleation. This the solid, the blue. So the solid, there are parts of liquid radius, and the radius is kanang sa tunga. So diameter is ana. Next is the nucleation. So this is the kanang diagram of nucleation. This is the formation of grains. So liquid, nuclei, liquid, the crystals that will form grains. So grain, boundaries, grains. So next, types of nucleation. So nucleation has two types. So homogeneous nucleation. So what is homogeneous nucleation? Homogeneous nucleation is the formation of the critically sized solid from the liquid by clustering together or large number of atoms of high undercooling. So the next is heterogeneous nucleation. So this is the formation of a critically sized solid from the liquid on the impurity surface. Heterogeneous nucleation occurs in a liquid on the surface of its container. So insoluble impurities and other structural material that lower the critical free energy required to form a stable nucleus. In a practice, homogeneous nucleation rarely takes a place of heterogeneous nucleation occurs either or the mold walls or the insoluble impurity particles. So this is types of nucleation. So nucleation are two types, homogeneous and heterogeneous. So this is the diagram of homogeneous and this is the diagram of heterogeneous. So the growth. Once solid nuclei form growth, occurs atoms are attached to the solid surface. So growth is the physical process by which its new phase increases in size. In the case of solidification, this refers to the formation of stable solid particle as a liquid freeze. So nature of growth of solid depends on how heat is removed from the system. Sensible heat and latent heat is to be removed. The manner in which latent heat is lost determines the growth of machines. There are two growth mechanisms. So one is the planar growth, two is the dendritic growth. So the difference in planar and dendritic growth arises because of the different sink of the latent heat. So this is the growth diagram of the growth. The solid, the liquid, and the plus VE, the T gradient columnar growth, the solid, the liquid, and the T gradient. So first is the planar growth. The heat is dissipated through the crystal EI from the ground crystal is cooler than the melt. Here a solid bulge into the liquid would melt again because of the temperature in the bulge in the above theme. Therefore, one obtains a stable flat solidification front. So, any small protuberance that begins to grow on the interface of the surrounded by liquid above the freezing temperature. The growth of the protuberance stops until the remainder of the interface catches up with it. This planar growth occurs by the movement of the smooth solid liquid interface into a liquid. So dendritic growth. So what is dendritic growth? For a strongly undercooled melt by the heat of crystallization can also be dissipated through the melt. Under this condition, a small solid protuberance called a dendrite, which forms at the interface encouraged to grow as the solid dendrites grow. The latent heat of fusion is conducted into the undercooled liquid, raising the temperature of the liquid towards freezing temperature. Dendritic growth continues until the undercooled liquid warms to the freezing temperature. Any remaining liquid in the solidifies the planar growth. These are the thermal dendrites different from dendrites in alloys. So this is the planar growth and this is the dendritic growth. So next is solidification defects. So shrinkage. Most materials contract to the shrink during solidification and cooling. Shrinkage is the result of three results. First is the contraction of the liquid as it cools prior to its solidification. Number two is contraction of during phase change from the liquid to solid. Third is, and lastly, is contraction of the solid in the continuous to cool to ambient temperature. Shrinkage can sometimes cause cracking to occur the component as a solidifies. So, gas porosity. Many metals dissolves a large quantity of gas when they are liquid. However, when metals solidify, they retain only a small part of the gas, but these form bubbles trapped into the solid metal producing gas porosity. Next is the design consideration in casting process. So to minimize the damaging effects of shrinkage, riser is used to casting process. So what is riser? Riser is a reservoir of molten metal to composite of shrinkage. This molten metal is continuously available from risers to prevent shrinkage voids. It is desirable for the regions of the casting most distance from the liquid metal supply to freeze first and for solidification to progress from these remote regions towards the riser. Directional solidification is obtained by using shields. Also, to minimize shrinkage problems, with final cast product allowance is given for the size of mold during pattern design. So, for the conclusion of this report, principles involved in the solidification of metals have been only discussed. Second is the solidification of alloys are much more complex and involves solute partitioning studies. The third and lastly is based on the solidification studies, design considerations were implemented in the casting process.
So let's move on to the rubber processing technology. Rubber processing and shaping, manufacture of tires and other rubber products. Product design, consideration. So nag-topic ni about sa mga sa pag-process ng rubber. So overview of rubber processing in products. Many of the production methods used for plastics are also applicable for rubbers. Kana nang mostly kay na-made na sad ang rubber tungod sa plastic food. So, however, rubber processing technology is different in certain respects in the rubber industry. Is largely separate from the plastics industry. So, ang kaning rubber ug ang plastic kay nay kalahian gyud. Ang rubber kay mas siya bitaw kanang ilado. Let's say kanang mas grow pa ang rubber kaysa sa plastic. And next is the rubber industry in goods made of rubber are dominated by one product, tires. Tires are used in large numbers on automobiles, trucks, aircraft, and bicycles. So, because kaning mga tires kay gamit yun siya, makita mo dyan na nato mostly common mo na sakyanan, kita yun na natong tires, kita yun na natong ligid, gamit yun kinang ligid sa to ang pag-transportation good. So mana nakagamit yun ang ang rubbers good kay naka made up good siya ba, so that nga natay transportation. Rubbers processing and shaping. Production of rubber goods consisting of two basic steps. So duha ka steps. Production of the rubber itself. Natural rubber is an agricultural crop. Synthetic rubbers are made from petroleum. So uban kay ang rubber kay nako lang kanang agricultural crop. Akuha lang diha. And production kay synthetic rubbers are made from petroleum. So nagikan sa petroleum ang uban nga rubbers nga gi-made of production. So processing into finished goods consisting of compounding, mixing, shaping, vulcanizing. So kana maning for nga kanang para ma-made up nga ang steps para makahimo og tawag na kanang rubber. Nag-talk about man ta kung unsa paghimo sa rubber. So pag-shape kana. The rubber industry's production of raw NR might be classified as an agricultural industry because latex, the starting ingredients, is grown on plantation in tropical climates. By contrast, synthetic rubbers are produced by the petrochemical industry. Finally, Processing into tires in other products, parcel processor, fabricator plants, commonly known as the rubber industry. The company names include Goodyear, BF, Goodrich, and Michelin, on reflecting the importance of tires. So kaning mga akong na-mention kay mga industries sikat nag-made of production tires. So commonly known is Goodyear, BF, Goodrich, Michelin, all reflecting the importance of the tire. So nagkuhan din sila nga sa importante gyud ang tires at kinabuhi. So next, production of natural rubber. So kaman to kanang sunod kay karon kay natural rubber sa ta. Natural rubber is taped from the rubber trees. Hevia brasiliensis as latex. The trees are grown on plantations in Southeast Asia and other parts of the world. Latex is a colloidal dispersion of solid particles of the polymer polysoprene in water. Kanang nakamade ang nakamade og natural rubber tungod sa latex. Kanang mga trees nga na tawag ng mga trees plantation kanang in Southeast Asia and other parts of the world. Naikalain mga lugar nga naghimo ani nga nga rubber. So mainly pod ang latex kay nagkuan pod sa kanang solid particles which is called polysoprene pod. Is the chemical substance that comprises rubber and content is the emulsion is about 30%. So next is the latex is collected in large tanks, thus blending the yield of many trees together. So na-mention ako trees natural rubber kay nagikan pod sa mga trees pod. So nila taka gi-blend nila as in para gyud makuan bitaw kanang maka made og trees giputo together gi-blend og maayo aron makabuo og rubber. So recovering the rubber. The preferred method of recovering rubber from latex involves coagulation, adding in acids such as formic acid, CCOOH. Coagulation takes about 12 hours. The coagulation of soft solid slabs and then squeezed through a series of rolls which drive out most of the water and reduce thickness about 3 mm 1/8 inches. So kani kay mga method ni aron pa recovering ang rubber. So ang gihimo nila kay tungod sa latex nag-involve sila coagulation, nag-add sila acid para para bitaw ma-recover ang rubber. So in 12 hours nagkuhan sila acid. So the column now soft solid slabs kung once ganin na mo soft na siya gi-squeeze sila maayo antod nga gi-roll gi-drive out nga ang tapos sa pagkaman nato gi-reduce nila ang thickness into 3 mm 1/8 inches. The sheets are then braved over wooden frames and dried in smoke houses. Several days are normally required to complete the drying process. So pag himo gyud og kuan tawag na natural rubber kay lisod jud siya. Dapat jud nay patient yun ang sa katawo kanang saludo jud ko ang mga industries gyud. So grades of natural rubber. So is good at mga grades. The resulting rubber now in form called reeved smoke sheet folded into large bales for shipment to the processor. It has a characteristic dark brown color. So kani kay para morning mga grades morning gi-called nga reeved smoke sheet. So nya color kay dark brown color. So, in some cases, the sheets are dried in hot air rather than smokehouses. The term air-dried sheet is used. This is considered to be a better grade of rubber. Manang gitaw nga better grade nga rubber is air-dried sheet. Still better grade called pale grip rubber involves 2 coagulation steps followed by warm air drying. Its color is light tan. So, kaning cold pane grip rubber kay isa better grade nag-involve siya 2 coagulation steps which is nga warm air drying manang kuan para makabuog yun yung color kay light tan. So next is synthetic rubber. Most synthetic rubber are produced from petroleum by the name polymerase techniques used to synthesize other polymers, unlike thermoplastic and thermosetting polymers which are normally supplied to the fabricator Pellet or liquid resin synthetic rubbers are supplied to rubber processors in the form of large bales. The rubber industry has used a long tradition of handling in these unit loss. So kaning synthetic rubber kay gimade yun, giproduce sa petroleum. So manang gigamit ang polymerization techniques para ma-synthesize ang mga polymers sa usa ka petroleum para maiwasan ang chemicals nga makadaot sa ato. So next is compounding. Rubber is always compounded with additives. Compounding adds chemicals for vulcanization such as sulfur. Additives include fillers which act either to enhance the rubber's mechanical properties, enforcing fillers, or to extend the rubbers to reduce cost. Non-reversing fillers. It is through compounding that the specific rubber is designed to satisfy a given application in terms of properties, cost, and processability. So, tungod din compounding kay naka-help siya para to design bitaw ang usa ka specific nga rubber na para makuha kung unsang application in terms kung unsang properties ana nga kanang rubber, kung unsang cost, kung unsang processability. So, ma-determine na tungod sa compounding. So, help gid na siya, big help na gid sa rubber. So, next is carbon black in rubber. The single most important enforcing filler in rubber by carbon black, a colloidal form of carbon obtained by the thermal decomposition of hydrocarbons soot. Its effect is to increase tensile strength and resistance to abrasion and tearing of the final rubber product. Carbon blacking provides protection from the ultraviolet radiation. Most rubber parts are black in color because of their carbon black content. So kaning carbon black in rubber kay tawagan na help siya sa ato ang pagdilipod. Kuan tawagan kay tungod ani kay ma-increase nato ang tensile strength kung unsa kuan kanang which maka-help sa ato agad. So carbon black also provides protection. So naka-help po siya protection sa ultraviolet radiation. Kay kaning radiation kay maka-affect ang gini sa atong panlawas, diba, sa atong skin, sa ato ang the way we live, makakuan gid siya, maka-cause gid siya sa ato. So next is other fillers and additives in rubber. China clays, hydrous aluminum silicates, COOH provide less reinforcing than carbon black but are used when black is not acceptable. Other polymers such as styrene, PVC, and phenolics. Recycled rubber added in some rubber products but usually 10% or less. Antioxidant, fatigue, and ozone protective chemicals, coloring pigments, plasticizers, and softening oils, blowing agents in the production of the foamed rubber and mold release compounds. So kani kanang other additives in rubber. So gisgot ni kung unsa mga some nga maka-feel diha sa mga rubber. So kana gihisgot na diha ang antioxidants dira mga polymers sa styrene, PVC, and phenolics ang addition nga unsay mga gamit sa rubber. So next is mixing. Kaduha mixing. Una kay compound nando, so next is mixing. The additives must be thoroughly mixed with the base rubber to achieve uniform dispersions of ingredients. Uncured rubber have high viscosity, so mechanical working of the rubber can increase its temperature up to 150 degrees Celsius and 300 degrees. If vulcanizing agents were present from the start of mixing, premature vulcanizing will result the rubber processes nightmare. So kana dapat yun ang pagmix kay kan bitaw kanang patient yun kay para makuha bitaw kung unsa ang desired nga ang rubber nga atong makuhaan gyud kay kung once gani na wala tay patient ang pagmix sa rubber kay maka-affect inuon, di na siya magamit, mahimo na siyang kuan tawagan na kanang reject ini nga na. So next is two-stage mixing. To avoid premature vulcanization, a two-stage mixing process is usually employed. Stage 1, carbon black and other non-vulcanizing additives are combined with the raw rubber. So kaning mga carbon black, non-vulcanizing additives kay gi-combine siya sa raw rubber, maning ang stage 1 nga pagkuan, stage 2 stage mixing process. So next is the term master batch is used for this first stage mixture. So mani ang kuan gi-call ni siya nga stage 1 as master batch. So stage 2, after stage 1 mixing has been completed in time for cooling that has been allowed, stage 2 mixing is carried out in which vulcanizing agents are added. So kana in stage 1, once kani ma-complete ang stage 1, i-mix nila ang kuan, tawag na kung unsa ang vulcanizing agents i-added nila. So filament reinforcing in rubber products. Many products require filament reinforcement to reduce extensibility but retain the other desirable properties of rubber. Examples: tires, conveyor belts, filaments used for this purpose include cellulose, nylon, polyester, fiberglass, and steel are used. Steel belted radial tires containing fiber materials must be added during the shaping. They are not mixed like the other additives. So kaning mga filament nga kanang mga wish nga gigamit sa rubber products. Example kay one of tires common gina siya. Conveyor belts kanang mga gigamit, belts kanang mga machines gamit kanang mga belts gyud, and etc. Shaping and related processes. Shaping process for rubber products can be divided into 4 basic categories: extrusion, calendering, coating, and molding, casting. Maniwa ko kanang steps sa pag-shape nato sa rubber nga product. So some products require several basic processes plus assembly work. Example, tires. Commonly na gyud ang tires sa to. Next is first ato compounding, mixing, and next katulo extrusion. Screw extruders are engineering used for extrusion for the rubber. Mani mga steps sa pag-shape guys. Mali na ko. Manang first step extrusion. The LD ratio of the extruder barrel is less than to thermoplastics. Typically is the range 10 to 15 to reduce the risk of premature cross-linking. Dye swell occurs in rubber extrudates since the polymer is in highly plastic condition, exhibits the memory property. The rubber has not yet been vulcanized. So before kita magkuha ka ng steps sa shaping, dapat mag-agi kita sa extrusion para kuan bitaw ang rubber kay ma-extrudates nato na malikayan nato ba kanang ang polymer kay since kay ang polymer kay highly plastic condition, malikayan nato nga ang atong rubber kay ma-plastic ba, mawasan ba nga kana mo na siya guys. So sunod is calendering. Stacks is passed through a series of gaps of decreasing size made by stand of rotating rules. Rubber sheets techniques determined by final group gap. So kanang calendering kay na series of gaps decreasing size made by pang integrate. So nakita naman natong kanang picture kana gi-roll nila. Roller dry process combination of extrusion and calendering the results better quality product later extrusion and calendering alone. So kay gamit niya kay ni siya sa pag-roll ba. Sa pag-roll nato kay makakuha gyud natong desirable nga texture sa atong rubber. So next is coating or impregnating fabrics with rubber. An importance of industrial process for producing automobile tires, conveyor belts, internally cooled cups, and waterproof cloth, tents, and raincoats. So kani mga important industries para makaproduce ta sa mga tires, conveyor belts, and rats. So next is molded rubber products. Molded rubber products include soles and heels, gaskets and seals, suction cups and bottle cups. Also, many foamed rubber parts are produced by molding. In addition, molding is an important process in the production. So, para makuha nato ang shape, dapat gyud nato i-mold gyud ang usa ka atong rubber nga product. So, i-mold gyud nato siya gyud. Molding process for rubber. Principal molding processes of rubber are compressing molding. So, kanang i-compress nato para mo-mold siya ba. Transfer molding and injection molding. Kang transfer molding, i-transfer nato, injection molding atong inject para makuha gyud nato ang desirable nga shape sa ato ang rubber. Curing vulcanization is accomplished in the mold in all 3 processes, this presenting a departure from the previous shaping methods, all of which use of a separate vulcanizing step. So curing ang other nga tawagan na process. So next is vulcanization. The treat that accomplishes cross-link of elastomer molecules so that the rubber becomes stiffer and stronger but retains its extensibility. On a submicroscopic scale, the long chain molecules of rubber becomes joined at certain tie points, the effects of which is reduce the ability of the elastomer to flow. A typical soft rubber has one or two crosslinks per 1,000 units meters. As the numbers are crosslinks increase, the polymer becomes stiffer and behaves more and more like a thermoplastic plastic hard rubber. So kaning aran nga once ka nang nay buslot ay kangisi pwede na to mga cross linking ba para makuan bitaw ka nang mamana ka nang kita man ta ng mga vulcanizing, no. So mga na nga style ba sa pag vulcanization sa to to link nga kuan kana mga separate pwede na to siya maisahan through heating kana compressing. So makuha na gyud na sa to kana gi kuan ni sa tawag nga steps gud siya. Effect of vulcanization rubber molecules kana through rubber and vulcanizing cross-link rubber organizations of include rubber kana vulcanization chemicals and times. As it was first invented by Goodyear in 1839, vulcanization used sulfur, about 8 parts by weight of, as mixed with 100 parts of NR at 140 degrees Celsius for about 5 hours. So, first invented kay Goodyear in 1939 ang vulcanization. 12 hours ilang ikuan pag-compress para makuha ang vulcanization. With sulfur alone is no longer used today due to long curing time. So, tungod sa kadugay, giwala nilang sulfur. Various other chemicals are combined with smaller doses of sulfur to accelerate and strengthen the treatment. So, nakakita sila nga pamaagi, parang paspas. The resulting cure time is 15 to 20 minutes. A variety of non-sulfur vulcanizing treatments have also been developed. Kana, kung sa itong nakita aron, sahod na kay 12 hours. Karon, pila na ka minuto, pabul kita, di ba? Dali na kayo, magwat lang tag 15 minutes or 20 minutes nga kuan. So, dito magwat og 12 hours. Tires and other rubber products. Tires are a principal product of the rubber industry. Tires about 70% of total rubber tonnage. Other important products: footwear, seals, shocks, absorbing parts, conveyor belts, hose, foam, rubber products, sports equipment. So kaning tires kay gamit gyud sa kini siya gyud mga products ba. So kana makita gyud na to commonly, makita gyud sa itong mga mata kanang mga kuan, labi ng kanang footwear. Kanang mga chinilas. Di ba? Kana. Next, tires. Pneumatic tires are critical components of the vehicles in which they are used. Function of vehicle tires: support the weight of the vehicle, passengers, and cargo. Transmit the motor tongue to propel the vehicle. Absorb road vibrations and shock to provide a comfortable ride. Tires are used on automobiles, trucks, buses, farm, tractors, each earth-moving equipment, military vehicles, bicycles, motorcycles, and aircraft. Kana ato na nabasahan nga kung unsa gi function sa tires gyud kana gi-use gyud siya sa vehicle gyud, mainly gyud sa vehicle gyud siya kay nga-provide siya kuan kana transportation, nag-absorb siya sa road vibration, shocks para dili ta magkuan kanang malipong, maiwasan na ingana. So next is tire construction. A tire is an assembly of many parts. A passenger car tire has about 50 individual components. A large earth mover tire may have as many as 175. The internal structure of the tire, known as the carcass, consists of multiple layers of rubber coated cords called plies. So kana ang tawagan na kanang internal structures of the tire kay ginon as carcass consists of multiple layers of rubbers nga nag-called og plies. So the internal structure of the tire known as carcass and that consists of multiple layers of rubber coated cords na gitawag og plies. And next is the cords are strands of nylon, polyester fiber, glass, or steel which provide an extensibility to reinforce the rubber in the carcass. So kana para mo-expand ang tire. Three basic of the tire constructions: diagonal ply, belted bias, and radial ply. So inumduma diagonal ply, belted bias, and radial ply. Maning consist kaning una kay ang radial ply, belted bias, and radial ply. The production sequence. Tire producing can be summarized in 3 steps. Performing of components. So, 1. 2. Building the carcass in adding rubber strips to form the slide wall in threads. So, ikaduha ang pag-build sa carcass. Molding and curing the component into one integral piece. So, para ma-mold into one piece sa ara ang tire kay mabuo ang production ba ma-form. Then following descriptions of these steps are typical. These are variations in processing depending on instruction, tire size, and type of vehicle in which tire will be used. So kanang nag-base gyud siya kung unsa kadako ang tire, kung unsa kalapad, kung unsa gyud ang gamit siya ha. Kay lain-laing tire kay lain pud ang pagka build kay kung dako ang tire, so dako pud kailangan nimo nga galamiton. So next is performing of components. The carcass consists of components of number of components which most of which are number or reinforced rubber. So this as well as the sidewall and thread rubber are produced by continuous processes and then pre-cut to size and shape for subsequent assembly. So ang carcass consists a number of components which are rubber or reinforced rubber. The components include bed coil, plies, inner lining, belts, thread, and sidewall. So inumduman na to. Components kay nag-include bed coil, plies, inner lining, belts, thread, and sidewall. So unom kabuok siya nga components. So building the carcass. The carcass is a traditionally assembled used a machine known as the building drum, whose main element is cylindrical arbor of that rotates. So kanang carcass kay machine siya nga known as building drum. So gamit ni siya para sa mga machines food. Molding and curing. The tire molds are usually split molds in contain the thread patterns to be impressed on the tire. So kaning carcass kay mo ning ang gihimo nga sa body pa mo ni ang bone sa tire. So mo ni ang kuan ta kanang abuto sa tire. So next is other rubber products. Rubber belts of conveyors and pulleys. Widely used in conveyors or mechanical power transmissions in systems, as in tires. Rubber is an ideal material for these products, but the belt must have little or no extensibility in order to function. Accordingly, it is reinforced with fibers, commonly polyester or nylon. Fabrics of these polymers are usually coated by the calendering, assembled together to obtain a required number of plies in thickness, and subsequently vulcanized by continuous or batch heating processes. So, other nga rubber products kaya rubber belts and conveyors and pulleys. So, para makamade kayo nga ning kuan tawagan ng mga kaning mga kuan kay dapat mo agi kag calendering assembled together. Next, ang final kay ang vulcanizing. So para mahimo gyud mo ngani nga mga products. Next is processing of thermoplastic elastomers. A thermoplastic elastomer is a thermoplastic polymer that processes the properties of a rubber. These are processes like the thermoplastics, but their applications are those of the elastomer. Most common shaping processes are injection molding and suction, which are generally most economical and faster than the traditional process used for rubbers that the most vulcanized. So kanang pag-process sa thermoplastic elastomer. So pag-process ani kay para injection molding instructions. So kanang three nga kuan ka ng mga processes para makamade kag thermoplastic elastomers. Next is TPE products. Molded products include shoe soles, athletic footwear, and automotive components such as fender, extensions, and corner panels. Extruded items include isolation coating, electrical wire, tubing for medical application, conveyor belts and sheets, and film stocks. No tire of TPE. So kaning TPE kay tawagan na kanang gimid ni para magamit sa to kanang mga tawagan na kanang ma-wear nato, sulob nato, magamit nato sa kuan pod sa mga electrical nga parts. Kabantay mo ng wire, di ba? Namo gyud na ang rubber kay para maiwasan ba para di ta makuryente. So gamit gyud na sila sa mga medical pod kanang mga tubes, kanapod mga tawagan na kanang basta gamit pod sa mga hydraulic pod. Next is product design consideration, economic production quantities. Rubber parts produced by compression molding, the traditional process can be often produced in quantities of 1,000 or less. The mold cost is relatively low compared to other molding methods. Injection molding, as with plastic parts, requires higher production quantities to justify the more expensive mold ko. Tungod sa mga mold pod, nagkamahal pod ang kuan tire. So, the more nga magmold ta, the more sad nga the more nga magmold ang tire, the more sad nga mo increase pud ang kuan ang sale pud dia sa kuan kung pila tagpila siya, mahal ba ang cost pud. Next is product design consideration. Draft is usually unnecessary for molded parts of rubber because its flexibility allows it to deform for removal from the mold. Shallow undercuts, although undesirable, are possible with rubber molded parts for the same reason. The low stiffness or high elasticity of the material permits removal from the mold. So kana tungod ani kay tawag na sa the low stiffness and high elasticity of the material permits removal from the mold. So kaning mga product nga dapat nga i-considerate nato sa tire.
Topic is shaping process for polymer matrix composites. So the shaping process for polymer matrix composites are involving the starting materials for PMC. So which is polymer matrix composites. So open mold processes, closed mold process, filament winding, filtration process, other PMC shaping process, or the polymer matrix composites shaping process. So next is the overview of polymer matrix composites technology. So, what is polymer matrix composite? So, it is a composite material consisting of a polymer embedded with a reinforcing paste such as the fibers in the powder. So, this is the importance of polymer matrix composites as the process derived from the growing use of this class of materials, especially the fiber reinforced polymers of the FRP. So what is the FRP composite? So can be designed with very high strength to weight and modules to weight ratios. So this feature make them the attractive in aircraft, cars, trucks, boats, and sports and equipment. So mo ang gamiton nila sa which is the trucks, the boats, and the other sports equipment. So next is the PM PMC shaping process. So many PMC shaping processes are slow and labor intensive. So in general, techniques for shaping composites are less efficient than the other materials. So nga naman, so why? Because composites are more complex than other materials, so consisting of two or more paces. So for FRPS, so there is the need to orient the reinforcing pace. So many new composites fabrication process in last 7 years, which is the SRMIP and the VARTM automated open mold and etcher. So the categories of FRP shape processes is open mold processes. So some of the original FR manual process of laying resigns to the fiber and to form. So number two is the closed mold processes. So this is much the same as the used to plastic molding. So next is the filament winding, which is the continuous filaments are dipped into liquid resin and wrapped around the rotating mandrel, producing a ragged, hollow, cylindrical shape. So filtration, it is a similar to extrusion, only adapted to filtration. So it is also similar to extrusion, only adapted to include continuous fiber reinforcement. So the other operations not the previous categories. So this is the this is the diagram of the classification of FRP processes. So this the this is the FR shaping the process for short fiber PMS. So this is the diagram and layup, automated tape laying. So this is composed in open mold processes. So in closed mold processes, this composed of compression molding, resin transfer molding. So the filament winding, the the filtration process, so the other tube is tube rolling, so the other mold process is spray up. So this is the diagram. So next is the polymer matrix. So thermos thermosetting, so which is the TS, the polymers are the most common matrix materials. So the principal TS polymers are there are two, which is the phenolics. So phenolics and the polyester and exposes. So what is phenolics? So it is used to particulate reinforcing paces. So the second is polyesters and exposites. So most closely associated with the FRPS. So there is the thermoplastic molding compounds include the fillers and reinforcing agents. Nearly all rubbers are reinforced with the carbon black. Carbon black. So reinforcing agents. So diri kay naa diri sa kuno no, sa na-discuss ang what is the reinforcing phases. So reinforcing agent is the possible geometries, so possible materials, particles and the flakes, then the almost engineering interest of the use. So possible geometries is the fibers, particles and the flakes. So possible materials are the ceramics, metals and others. So polymers or elements such as the carbon or boron. The particles in the flakes are used in many plastic molding compounds. So, of most engineering interests and use the fibers as the reinforcing base of this is the under of reinforcing agent. So next is the fiber as the reinforcing base. So here is the reinforcing agent and these are the reinforcing base. So what's then in common in the reinforcing peso, the common fiber materials, which is glass, carbon, and the Kevlar polymer. So, in some fabrication processes, the filaments are continuous, while in other, they are chopped into short lengths. So, in continuous form, individual filaments are usually available as the rovings collections of untwisted continuous strands, convenient from the handling, and by contrast, a yarn is a twisted collection of the filaments. Next is the fiber on the reinforcing paste yapon. So the most familiar form of the continuous fiber is a cloth. So kabantang sa yung cloth. So a fabric or woven yarn. So it's a made of yarn. So the similar of cloth is a woven roving. So a fabric consisting of untwisted filaments rather than the yarn. So woven rovings can be produced with annual numbers of the strands into direction so that they possess greater strength in one direction, so such as unidirectional woven rovings are often preferred in laminated FRP composites. So next is the matte iron performs as reinforcement. So fibers can also be in the matte form. So a felt consisting of randomly oriented short fibers held closely together with a binder. So mats are the commercially available as the blankets of various weights, thicknesses, and the widths. So mats can be cut and shaped for us in the performs in some of the closed mold processes. During molding, the resin impregnates soap the perform of the course. So this yielding a fiber reinforced molding. So this is the combining of matrix and reinforcement. So the starting of the materials arrived at the fabrication, the operation is the separate intense and the combined into the composite during the shaping. So the filament winding and the filtration in which reinforcing peso, it was a continuous fiber. So the two component materials are combined into some starting form. The used in the shaping process are the molding compounds and the prepreg. So ma-discuss ni ig sa next ani nga kan. So what is the molding compound? So it is the composite molding compounds consist of the resin matrix with a short randomly disappeared fiber. So The similar to those used in the plastic molding are the most molding compounds are composite processing are the thermosetting polymers. So since they are designed for the molding, they must be capable of allowing. So accordingly, they have not been cured prior to the shape of processing. So curing is done during and or after final shaping. So what is prep preg? So this is the fibers impregnated with the partially course of these resins to the facility shape of processing. So the available as the tapes with the cross-plied sheets of fabrics and the curing is implanted during and or after shaping. So the advantage of this is prepegs are the fabricated with continuous filaments rather than the shape random fibers, thus increasingly strength and the modulus. So the open mold processes, so the family of FRP shaping processes that use to a single positive or negative mold surface to produce laminated FRP structures are the starting materials, which is the resins, fibers, mats, and the woven roving. So this applied to the mold by layers, so building up to the desired or of thickness. So this is allowed by curing and part removal. So common resins are the unsaturated polyesters and the epoxies using the fiberglass as the reinforcing. So epoxies and the polyesters. So the open mold or the FRA process are there are four. So which is the hand layup, the spray up, so the bagging, so which is uses to hand layup or uses atmospheric pressure to combat laminate. So number four is automated tape laying machine. So the difference are in the methods or applying. So this is ang naka-difference ng ani kay ang pag-apply sa lamination to the mold to alternative curing techniques and other differences. So, ang pag-use or ang pag-apply ang naka-differentiate. Next is the hand layup method. So, excuse me. So, the hand layup method. So, this is an open mold shaping method in which is successive layers of the resin and reinforcement are manually applied to an open mold to building the laminated FRF composite structures. So, the labor intensive to finish the molding must usually be trimmed with a power saw to size outside edges. So, all this open mold method o laminates dating to the 1940s. So, dugi na kayo when it was first used for both holes. So, ang nakauna ni di ay gamit kay ang for the both holes. So, this is laminates of 1940s. So, dugay na. So, next is this is the diagram of hand layup method. So, this number one is the mold is treated with the mold release agent. So this is the picture. So the next is the thin gel coat which is resin is applied to the outside surface of molding. So this is the coat. Next is the number 3 is when gel coat has partially set, layers of resin are the fiber are applied. The fiber is in the form of mat or cloth. Each layer is rolled and to impregnate the fiber with resin and the removal air. So, this is the layers of the removal resin ni double. So next is the number 4 is the part of cured. So kanina nagkuan ng mga excuse. So number 5 is the fully hardened part of removed from the mold. So sapawan. Ay sapaw pero dire gikuha ang finished part of the ready removal trimming. So ibutang na nga re. Next is the products made by hand lay up. So these are the products nga na made sa pag hand lay up. So generally large in size but low in production quantity, not economical for high production. For the application of this is the boat holes kato kaniya, swimming pools, large container tanks, movie and stage props, other form sheets. So The largest molding ever made was the ship hull so for the British Royal Navy, which is 85 meter or 280 feet long. So taas-taas yun. So next is method is the spray up method. So spray up method. So liquid resin is the chopped fibers that spread into an open mold to the build's successive FRP laminations attempt to mechanize application for the resin fiber layers and reduce layup time. So alternative for step is 3 in the hand layup procedure. So there are 3 layup procedures. So products made by hand layup. Dili man. So this is the diagram of spray up method. So spray up method. This is the diagram of spray up method. So products made by spray up method. The products are the boot holes, bathtubs, shower, stools, automobile, and the truck body parts. So recreational vehicle components, furniture, large structural panels, and the containers. So movie and stage props is sometimes made by this method. So since products made by the spray up have randomly oriented short fibers, they are not as strong as those made by layup. So in which the fibers are continuous and directed. So this is kani vacuum bagging. So this is the kanang actual picture. Excuse me. And this is the kanang the diagram. So use atmospheric pressure to suck air from other vacuum bag. So to compact combustible layers down and make a high quality laminate. So the layers from bottom include the mold release, the composite, and the pel ply breather cloth. Vacuum bag also need the vacuum valve sealing the tape. So kani diri kay naa ni siya yung mga di ipakita na sa diagram is ang mga parts niya. So these are have many parts. So next is the automated tape laying machines. So automated tape laying machines operate by dispensing a prepared tape onto the open mold following the program path. So the typical machine consists of overhead gantry, which is the dispensing head to attach. So the gantry permits is the YZ travel to the head for the positioning and following the defined continuous path. So next is the actual picture of automated tape laying the machine. Oh. This photo is courtesy by Cincinnati Milacron. So this is the picture. This is the Milacron, which is the company. This is the picture. So next is the carrying on open mold processes. So carrying is the required all of all thermosetting resins used in FRM laminated composites. So curing across links, the polymer transferring it from its liquid or highly plastic condition into the hardened product. So there are 3 principal process parameters in curing, which is the time, the temperature, and the pressure. So the curing at room temperature. So curing normally occurs the room temperature for the TS resins used to can lay up and spray up the procedure. So moldings made by these processes are often large to both holes and heating would be the difficult due to the product size. In some cases, these are required therefore room temperature curing the sufficiency complete to remove the part. So the curing methods based on heating. So even curing provides the heat at closely controlled temperature. Some curing ovens are equipped to draw the partial vacuum. In infrared heating used the application where it was impractical to the place molding it oven. So curing in the autoclave an enclosed chamber equipped to apply heat and or pressure at the controlled level. So in FRF composites processing, it is usually large horizontal cylinder with doors either in end. So the classification of closed molder process are these. So there are 3 classes based on their counterparts in conventional plastic molding, which is the compression molding, the transfer molding, the injection molding. So this terminology is often different for the polymer matrix composites are molded. So the compression molding or PMC process is the charge is placed in the lower mold section and the sections are brought together under the pressure causing charge to take the shape of the cavity. So the mold hubs are heated to cure these polymers. So when molding is sufficiently cured, the mold is opened and part is removed. So the several shaping processes for PMCs based on the compression molding so the difference are the mostly in the form of the starting materials. So the transfer molding or PMC processes is the charge of thermosetting resin which is short fibers is placed in the pot or chamber heated by the squeezed by the ram action into one or more mold cavities. So the mold is heated to the curve in the resin. So the name of the process derives from the fact that the fluid polymer is transferred from pot into mold. So the injection molding PMC process is the injection molding is noted for the low cost production of plastic part in large quantities. So although most closely associated with the thermoplastics, the process can also be adapted to the thermosets. So the process of interest is the context of PMCs, conventional injection molding, and the reinforced reaction injecting molding. So the conventional injection molding is the use for both TP and TS type of FRPs. So virtually all TPs can be reinforced with fibers. So sharp fiber must be used. So continuous fibers will be reduced by the action of the rotating screw in the barrel. So during the injection into the mold cavity, fibers tend to become aligned as they pass to the nozzle. So part designers can be sometimes exploit this feature to optimize directional properties in the part. Also, this is the reinforced reaction injection of molding. So reaction injection molding, which is the RIM, and the reinforced reaction injection molding, which is the RRIM. So what is the reaction injection molding? What is the reaction injection molding? So this is the two reactive integrated are mixed in the injected into the occur due to chemical reaction while is the reinforced reaction injection molding is the similar to RAM but includes reinforcing fibers, typically the glass, the fibers in or the mixture. So the advantage of this is the similar to RAM though, so not heat energy required lower cost mold. So with the added benefit of fiber reinforcement, the products of this is the auto body, the truck cab, the application is this is for bumpers, fenders, and other body parts. So next is the filament winding. So resin impregnated continuous fibers are wrapped around the rotating mandrel that has the internal shape of the desired product of the resin. In this cord of the mandrel removed. So the rovings are pulled through the resin path immediately, therefore being wound to helical pattern onto the mandrels. The operation is repeated for the conditional layers, each having the crisscross pattern with the previous until the desired path thickness has been obtained. So, papagaon jud maayo. So this is the diagram for the filament winding. This is the diagram. So this is the diagram for filament winding, which is the continuous roving kani. So the resin bat kani kaning kani 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 kaning box. So the pulleys kani ang kaning magtuyok nga mukuha ani daganan sa mga excuse me PC. So next is the carriage. So this So the driver box kani, the rotating kani ka magtuyok. So this is the diagram of filament winding. So balik sa nato. So these are all our topics, and thank you.